Welcome to Lesson 6 in the Mr. Circuit Lab on digital logic gates. In this lesson, you will learn about the NOR digital logic gate. A NOR digital logic gate can have as many inputs as needed. The one we will explain has two inputs, and therefore there are four possible combinations of input states as shown on the truth table. The first possible input combination is a 0 on input A and a 0 on input B. The second is 0, 1. The third is 1, 0. And the fourth is 1, 1. Remember that a 0 is a false and 1 means a true. On a NOR digital logic gate with only two inputs, if either input is true, the output will be false. Otherwise, the output is true. The general rule for the NOR digital logic gate is stated as follows. The output of a NOR digital logic gate is false if either or all of the inputs are true. Here is a practical example. Input A is, it is windy. Input B is, it is cold outside. Output Q is I will not wear a jacket. Since with the NOR gate, if either input is true or both inputs are true, the output is false. This means that if it's windy or if it's cold outside or both, I will not wear a jacket is false. Here is the symbol for a two-input NOR digital logic gate. Look at it carefully. The symbol has a curved top and bottom with a point on the right side just like the OR gate. But it also has the not circle on the output to indicate that its output is the inverse of the output of an OR gate. And it has two inputs, A and B on the left side, and one output Q on the right. Building an electronic NOR digital logic gate. Here is a schematic diagram for an electronic NOR digital logic gate. In this Mr. Circuit Digital Logic Gate Lab, as part of your training, you will construct this circuit on a solderless circuit board. Let me explain the circuit. You will notice that this circuit has two transistors, one LED, 4 resistors, a 9-volt battery, and two normally open push-button switches. As in all digital logic gate circuits, when the LED is lit up, it means there's a true on the output. Now let's talk about the transistors. Remember that when a transistor is forward biased, it means that it has the correct voltages on its pins to allow electron current to flow through it. Here we have two transistors. When you press switch S1, you forward bias transistor Q1, and when you press S2, you forward bias transistor Q2. In this NOR digital logic gate circuit, the engineer designed it so that the LED will light up when the transistors are not forward biased. But if you forward bias either one or both of the transistors, the LED will turn off, indicating a false on the output. So when you press switch S1, you forward bias transistor Q1 so that all the current will flow from the negative of the battery through the transistor Q1, through resistor R4, through resistor R1 to the positive of the battery. The LED will then turn off. Likewise, when you press switch S2, you forward bias transistor Q2 so that all the current will flow from the negative of the battery through transistor Q2, through resistor R4, through resistor R1 to the positive of the battery. Again, the LED will turn off. And When both switches are pressed simultaneously, the path for the current is through both transistors and the LED will turn off, indicating a false on the output. If you do not press any switch, which is the equivalent of putting a false on both inputs, the LED will light up, indicating a true on the output of the circuit. So as you can see from this explanation, this circuit works like a NOR digital logic gate. When either input is true, the output will be false. That is to say, when you put a voltage on the input of either transistor or both transistors simultaneously, the LED will turn off, indicating a false on the output. Now that you understand how an electronic circuit for a NOR digital logic gate works, you're ready to build one as part of your training, following the step-by-step instructions in the Lesson 6 booklet. Understanding these logic gate concepts will open up your opportunities into the fields of digital design and maintenance of computers and similar devices. When you complete this lab, you'll be eligible to receive your certificate of electronics training that you can display and add to your resume. If you need the Mr. Circuit Lab 3, go to www.mrcircuittechnology.com. Thank you from all of us here at the Mr. Circuit Technology Company for using the Mr. Circuit Labs to learn electronics to further your career.